In this video, we find out how to teach Fusion how to clear our pretend toys from our pretend swimming pool. How can we do this? In this fourth video of the Clear the Swimming Pool Challenge, we bring our previous Edge-Follow function and our previous SUMO function together into the one program. There are 4 steps in solving this challenge. Firstly, this is our pretend windy path through the pretend wilderness. We could teach Fusion to use the Edge-Follow function in this part of the arena. Secondly, this is our pretend silver sand beach. We can use Fusion's sensor to detect when Fusion reaches it. When the beach is detected, we can stop Fusion from using the Edge-Follow function, ready for the next step. Thirdly, when the pretend silver sand beach is reached, we can teach Fusion to go forwards into what we hope will be roughly about the middle of our pretend swimming pool. And then fourthly, we can teach Fusion to start using our SUMO function to clear our pretend toys from our pretend swimming pool. Well, our task is now to see if we can use Blockly and Python code to teach Fusion how to follow this plan to complete this challenge. This is the main program, which will be very similar to the one which we used in our Blockly course, the introductory course, which we assume that you've looked at. Now, it's very similar, except in one way. We've used a lot of comments. Most programmers I know in practice don't like putting comments in. They just want to get on and get the work done. But if you're working in a team and you've got other people trying to understand your code, comments are really important. We can see with this code that if the optical distance sensor doesn't see a very high reading, that is, it hasn't reached the silver sand, then it does this code, which edge follows. When the optical distance sensor does see the silver sand, it uses this code. It drives forward a little bit to roughly the middle of the swimming pool and then goes into an infinite repeat with SUMO with this code. And so that's how we want to solve our swimming pool problem. But let's look at the individual SUMO and the Edge-Follow functions. This is our Edge-Follow function with comments added in, and you'll notice that the comments are important in this way, in that it tells us what the decision point is. It's the average of the black and white sensor readings. We'll have to modify that later on. This is our SUMO function with comments added in. Again, we'll need to modify the 515, because that almost certainly won't suit the light conditions in our particular room. It would be wise to check the value of the optical distance sensor readings on our swimming pool arena. If you are uncertain how to get these readings, revise the earlier tutorial, How to Use Fusion's Optical Distance Sensor, FP11d. A problem can occur if the light levels on the swimming pool arena are too bright. We can have problems caused by the optical distance sensor saturating, that is, readings of 1023. For example, if the silver sands and white readings are both 1023, it will be impossible for Fusion to detect the differences between them. Generally, we'd like a difference of something like 100 between the two readings, and more than 100 would be preferred. How can we fix this? This problem can occur if the arena is in direct sunlight. If so, draw the curtains or move the arena into a shaded area. If this does not work, the optical distance sensor can be raised one hole higher on Fusion's front panel, but with the disadvantage that this makes the optical distance sensor mounting less stable, and the edge following can also be less exact. These are the readings we obtained on our arena. We can now use these in our Blockly and Python code. In our room, the white value seen by the optical distance sensor was 642, silver was 911. The average of these is 776.5, and so we'll use 777 as the decision point between white and silver. For our edge following function, the decision value is the average of the white and black readings, which is 384. For our SUMO function, the decision value is the average of the white value of 642 and the green value of 217, which is 429.5. We'll probably use 430. But there is one additional extra thing we have to think about. In our original SUMO, we wanted our robot to charge forward on a white center and then turn around when it found a black rink. In the swimming pool, we wanted to do the opposite. We wanted to charge forward in the dark green center and then turn around when it finds the white surround. So we'll have to change the greater than to a less than sign. Well, this is the final Blockly program. For the swimming pool challenge, we've made changes to the main program decision point, to the Edge-Follow decision point, to the SUMO decision point, and also some changes within the SUMO to make allowance for the fact that it's a dark center and a light surround. And we've made changes to the comments as well to show that. On the right-hand side of the screen, you can see the Python equivalent of the Blockly program. Now, if we go up to the little black symbol on the left, we can transfer that Python into the Python editor, and you can see here the complete Python equivalent of our Blockly program to solve the swimming pool challenge. You can see in our Python program that we have the initial declarations that we need for Python to be able to talk to our Fusion robot. Then we have the Edge-Follow function, and after that the SUMO function. These functions have to be defined before we have the main program. In Blockly we can put the functions all over the place. In Python they have to come before the main program. And then we have the main program, which brings everything together. Let us look at how the new Python commands compare with the old Blockly commands. We will look at the Edge-Follow function first. In Python, we have the Edge-Follow title for the function here, followed by the keyword def, which we need at the start of every Python function. We next have two comment lines. One-line comment in Python start with the octothorpe, also called the hash or the pound symbol, and we can continue to type our comment until the end of that line. Next we have the decision statement in Blockly. The read optical distance sensor from port 0 statement in Blockly is fairly clear, but it's not so clear in Python. In Python, the Fusion software has already defined for us a variable which it calls ODS_A0 at the beginning of the program. We can change this later on if we want to, but at the moment let's leave it that. Now, it's defined that before we use the function Edge-Follow. Now, this statement connects the variable name ODS_A0 to Fusion's optical distance sensor, which is plugged into slot A0. To read the value of the A0 optical distance sensor, we attach a .read followed by brackets to the variable ODS_A0. Even if you want to tidy up this Python statement by removing the round brackets, please don't do so. The round brackets are important in Python. Leave them in. Next we have a comment and two motor speed commands which cause Python to turn to the left when going forwards. And lastly we have a comment and two motor speed commands which cause Fusion to turn to the right when going forwards. Now that's all for the function itself, but when we look at the top we note that we have not used time anywhere in our Edge-Follow function. If Edge-Follow was the only function we used in our code, we would not need that import time command at the top of our Python program. However, we will see that it's needed in the next function we'll look at, the SUMO function. So let's look at the SUMO function. Time is used twice in the SUMO function, and so we'll need to import time at the head of our program. But let's look at the rest of the SUMO function. In Python, we have the SUMO title for the function preceded by the keyword def, which we need at the start of every Python function. We next have two comment lines. One-line comments in Python start with the octothorpe, also called a hash or a pound symbol, and we can continue to type our comment until the end of that line. Next, we have the decision statement in Python. The Fusion software has already defined a variable, ODS underline A0, at the beginning of the program, before we use the function SUMO. This statement connects the variable name ODS A0 to Fusion's optical distance sensor, which is plugged into the slot A0. We have defined this before for the Edge-Follow function, and we don't need to define this twice. Once is enough. To read the value of the A0 optical distance sensor, we attach a .read followed by brackets for the ODS underline A0 variable name, and its value can then be compared to the green-white decision value of 430. The next statement is a comment and a motor speed command which causes Fusion to charge forward in the hope of pushing a toy to the edge of the pool. Then we have a comment and a motor speed command which causes Fusion to back away from the white edge of the pool. And lastly, we have a comment and a motor speed command which causes Fusion to spin on the spot, ready to start another forwards charge in the hope of finding a toy to push to the edge of our pool. Now let us look at the main program. First, we have a while true statement in Python. Everything below that is indented one tab, so this repeat while true statement will apply to the whole main program. Our Fusion robot will keep obeying this program until we actually physically stop it. The next line compares the optical distance sensor to the reading of 777. If the reading is found which is below 770, it will obey the Edge-Follow function call at the bottom of the program. If the optical distance sensor sees a reading greater than 777, it then jumps to the three comments in the Python program, which are two comments in the Blockly program. You can see them here. The one motor command in Blockly becomes two motor speed and one time command in Python, the purpose of which is to cause our Fusion robot to leave the silver sand beach and advance towards the middle of our pretend swimming pool. Python then goes into a while true infinite loop where it calls our SUMO function continually. This will cause our Fusion robot to attempt to push toys to the edge of the swimming pool without stopping, until our Fusion robot either runs out of battery or we pick it up and stop the run. Now, that is our Fusion program which has been translated from Blockly. Let us see how it runs. You will notice this robot's a little bit different. The back optical distance sensor on the top is not used, and the optical distance sensor I'm actually using is mounted inside the front flange as an experiment, and you'll see it works quite well. So we can put the optical distance sensor either inside or outside the flange. I think in line following it'll probably work a bit better outside the front flange. Let's speed it up a bit to 2 times ordinary speed. Yep, and eventually it managed to push them all out. Okay. Well, the code worked nicely. And thank you for watching this video.